Hi, I am Clarice Oñate,
And I am Qasiana Ermino.
and we are a BS Chemistry student from the PAMANTASAN ng LUNGSOD ng Maynila.
For the complete hydrogen-like bound state wave function, we'll be using the value of psi, which is equal to the product of the eigenvalues of the region and the harmonic function. Recall that for the 8j orbitals, we have the values of its quantum number. N is equal to 8, L is equal to 7, and the ML that we're gonna be solving is the value of positive and negative 3. Solving for the region function, we have the value of R equal to E raised to negative ZR over NA times R raised to L multiplied by the summation of B sub J R raised to J from J is equal to 0 to J equals to N minus L minus 1. And for the harmonic function, theta equal to sine raised to M theta and multiply to the summation of AJ cosine raised to J theta from J is equal to 0 to J is equal to L minus M. And for the phi function, equal to 1 over the square root of 2 pi multiplied by E raised to I M phi. So, this is the complete hydrogen-like bound state wave function of the 8j orbitals. Solving for R, we have E raised to negative ZR over 8A multiplied by R raised to 7 times B sub O. So, to solve for B sub O, we have to do normalization. To normalize the equation, we have to equate the value of the integral of R star multiplied by R times R squared dr to 1. In doing so, we get the expression 1 is equal to B sub O squared times the integral of R16 e raised to negative 2 ZR over 8A dr from 0 to infinity. From the table of integrals, we get the expression n factorial over q raised to n plus 1 to solve this equation. So, substituting the value of n is equal to 16, x is equal to r, and q is equal to 2z over 8a, and solving the function, we get the expression r is equal to 1 over the square root of 16 factorial multiplied by the value of 1/4 times z over a raised to 17 over 2 multiplied to e raised to zr over 8a multiplied by r raised to 7. So, theta is equal to sine raised to the absolute value of n multiplied by the summation of a sub j times cosine raised to j from j is equal to 0 to j is equal to L minus the absolute value of m. So, theta is equal to sine cube multiplied by the value of a sub 0 plus a sub 2 cosine squared theta plus a sub 4 cosine raised to 4 theta. So, since we have three different terms, we use the recursion equation, which is equal to a sub j plus 2 is equal to j plus the absolute value of m multiplied by the value of j plus the absolute value of m plus 1 minus L multiplied by L plus 1 over j plus 2 times j plus 1 multiplied by aj. So, solving for the value of a sub 2, we get the a sub 2 is equal to negative 22 a sub 0. So now, we're gonna be solving for the value of a sub 4. To do so, we use the same equation that we used before, which is the equation for the recursion relation. So, aj plus 2, substituting the values, we get the values of a sub 4 is equal to negative 13 over 6 multiplied by A2. So, A sub 4 is equal to negative 13 over 6 multiplied by A2. So, to eliminate A2, we will substitute our value of negative 22 times A sub 0. So, in doing so, we get A sub 4 is equal to 143 over 3 times A sub 0. So, since we already have the value for A sub 2 and the value for A sub 4, we now substitute it to the equation that we have before. So, sine cube theta multiplied by the value of A sub 0 minus 22 A sub 0 cosine squared theta plus 143 over 3 cosine raised to 4 theta. So, solving, as we have done before, we are going to perform normalization. So, we're gonna perform normalization to get the value of A sub 0. To do so, we have to equate the integral of S star times S sine theta d theta from 0 to pi. So, we'll have the equation of 1 is equal to the integral of A sub 0 sine cube theta multiplied by 1 minus 22 cosine squared theta plus 143 over 3 cosine raised to 4 theta squared multiplied by sine theta and d theta. So, since we get a trinomial and we have to square it, we use the shortcut method. So, in the form of A minus B plus C squared, its answer will be A squared plus B squared plus C squared minus 2AB minus 2BC plus 2CA. In doing so, we get its product of, we get the product of 1 plus 484 cosine raised to 4 theta plus 20,449 over 9 cosine raised to 8 theta minus 44 cosine squared theta minus 6,292 over 3 cosine raised to 6 theta plus 286 over 3 cosine raised to 4. So, solving the function, we get the value of 1 is equal to A squared multiplied by 4.0947 times 10 to the negative 7. So, to get the value of A sub 0, we get the reciprocal of 4.0947 times 10 raised to negative 7. So, A sub 0 is equal to 1,562.75. So, after getting the value of A sub 0, we now put it into our equation, and we have now theta is equal to 1,562.75 sine cube theta multiplied by the value of 1 minus 22 cosine squared theta plus 143 over 3 cosine raised to 4 theta. And lastly, we're gonna solve for the value of phi. Phi is equal to 1 over the square root of 2 pi times e raised to positive negative I m phi. So, substituting positive 3 and negative 3 for the value of m, we now get the value of phi is equal to 1 over the square root of 2 pi times e raised to positive negative 3 I phi. So, substituting the eigenvalues of the radial function r and the harmonic functions theta and phi, we now have the complete hydrogen-like bound state wave function for 8j orbitals. ML is equal to positive and negative 3.